Mr. Suharto, are you audible? Am I audible? I already set this meeting into live on YouTube, so the screen and everything is yours.
Assalamualaikum, Mas Harto. Assalamualaikum, Bu Kapus.
Salam, Pak.
Lelang, Ibu. Ini di
Assalamualaikum Ibu.
Salam. Is it okay with recording?
Yes, yes.
Yeah, there is no problem with technical.
No, no, no.
Okay.
Hello, Harto.
Hello, Gyöngyvér.
To
Glad
tell
you
the truth, I was waiting in a different Zoom room, and there are also some others there. What you have sent me yesterday.
Really? Sorry.
Yes,
I
yes. So I was there. I was waiting for 10 minutes there
okay.
with
Sorry.
two other colleagues. So
Oh, yeah.
okay.
Yeah. I think the link the Zoom link is same, but okay, because we are late for 7 minutes. I think I should start the sharing session. Okay. Firstly, good afternoon, everyone, and welcome to the sharing session of Research Center for Education at National Research and Innovation Agency, that we call it BRIN. Okay, today's sharing session, we will discuss an important topic for transformation of digital education in testing, which entitled technology-based testing. Firstly, I have to introduce our honor speaker, Professor Gyöngyvér Molnár from University of Szeged, Hungary, and our head of Research Center for Education, Dr. Trina Vizanti. Dr. Trina, and then before we start, there is some rule that I want to explain to you. If you have a question, maybe you can drop or write your question in the chat box. And if you have a question in Bahasa Indonesia, please write it, and I will help to translate it into English. And during the session, please, I hope you can unmute yourself so it cannot give a noise to the sharing session. Okay. Before we start, our head of Research Center for Education, Dr. Trina, will give an opening remarks to this sharing session. Okay, Dr. Trina, the stage is yours.
Okay, thank you, Suharto. I think the Hungarian words on good morning because you are in. Okay, sorry. Yeah, okay. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Yeah. Good morning to Professor Gyöngyvér Molnár. It is nice to see you here, and it is a honor for us to invite you to be our guest extreme speakers, yeah, in this sharing session. Thank you to Dr. Suharto already arranged everything for this sharing session, and also to our young researchers who involved in this sharing session, and also to our participants. This is not only BRIN's researchers, but also we open this sharing session to public. So I hope that we can get productive discussion later. So actually, based on the we see that based on digital education outlook, 2023, from the OECD and an organization that monitor quality of education on PISA report, Hungary is one out of the 29 countries that successfully applying transformation of digital assessment and evaluation. So in today's sharing session, Research Center for Education at BRIN invite one of role model that understand theory and practical of technology-based testing in Hungary to explain her expertise and experience to us. So we really welcome Professor Gyöngyvér Molnár. She is a full professor and the head of Institute of Education, and also as the head of the Doctoral School of Education at University of Szeged in Hungary. So the best state university in Hungary on education, yeah. So her main areas of interest include technology-based assessment, improving cognitive skills, studying the quality of school learning, and the potential for using ICT in education. So all of which are aimed at improving the quality of learning. So I think she's expert on the that we really need to discuss later with her. And without overdue, I hope that we can have a productive discussion. And thank you again. And to all participants, please use this sharing session as the way to discuss about the ICT in education. Thank you very much, Dr. Suharto.
Thank you, Dr. Trina. Okay, next, Professor Gyöngyvér Molnár will give explanation for their material. Okay, Professor Gyöngyvér, the stage is yours. You can start.
Thank you. So I strongly hope that you can see my slide.
Yes, we can see it.
Yes.
Okay. So let's start. It was a nice journey for preparing this presentation, and so thank you again for the invitation, because I made thought about the topic, what should it goes about, and then I decided to bring you through the past, what we learned it in Hungary and what the international community have learned in the past 25 years in the field of technology-based assessment. So let's start this journey and turn back to nowadays. Nowadays, what's the case? Your smartphone offers workout and nutrition programs if you decide to put on muscles or to lose weight after entering a few important parameters like height, weight, age, gender, and of course your goal. As you do sport more, your smartwatch continuously monitors your time, calories burned, pulse rate, heart rate. More accurate, personalized workout programs are provided for you based on these data. And now the question can be raised, what is in the background? What do you need to realize this? And at this point, we are there by technology-based assessment, because in the background, there is technology-based assessment. What do you need to realize it? Infrastructure, of course. Assessment, data, data, and data, so big data, evaluation of these data, and of course, personalized feedback. This is the case in the field of education too. The title of my presentation includes the term, according to Suharto's suggestion, technology-based assessment. Technology-based assessment is an umbrella term. It covers all kinds of assessments, which somehow includes technology by the data collection or by the data analysis or by giving the feedback or by administering the tests. So technology-based assessment includes all of these kind of assessments. A narrower group is computer-based assessment, and again, a smaller group is network-based assessment, which was also very important in the around the millennium. And the smallest group is online internet-based assessment, which is nowadays the really widely applied type of assessment. So I Googled it yesterday in the Scopus, and if you take a look on the figure, you can see that technology-based assessment is still an issue, and the amount of papers published in this topic regarding this topic in the field of education is still increasing. But let's turn back to the beginnings. Let's see the beginnings. The beginnings started is in the field of education in 1920, when more than 100 years ago, yes, when Sidney Presley automatic testing machine was applied and launched at university level. The next big step was a few years later in the field of, again, technology-based assessment, and the IBM model in 2005 was launched, realizing the testing millions of Americans in a type of objective test. And again, a short break, and language testing was which gave an impetus in the field of computer-based assessment. And the next big step happened in the 90s and around the millennium, where the World Wide Web was introduced and spread, and large-scale assessments started. Infrastructure was available, more or less. And at that time, if we look around the studies, the researchers in the field of educational assessment, then we could see a really different type of researchers. Some of the researchers focus on really cheap technologies, but we can even see researchers in the field of educational assessment which use cutting-edge technology. At that time, it was really cutting edge. If we talked about gaze tracking, heart breath rate measuring, breathing rate measuring, brain activity measuring. So that was the time when the infrastructure was more in the focus than the testing itself. And afterwards, researchers decided, because of the availability, because of the many possibilities, by the computer. And so we turned to computer-based assessment, and it became the main issue in the field of educational testing. In the presentation, I will go through this path from 1919 until nowadays, how computer-based assessment developed, technology-based assessment developed, what kind of researchers can we meet through this path, and I will also introduce you some of our main results in this period. So let's see the first, so we can distinguish 4 different generations of testing. The first generation testing, automated administration was in the focus, and mainly the comparison of paper, pencil, face-to-face, and computer-based assessment. The second generation, adaptive testing, became in the focus, and we started to think about the reinvention of testing, educational assessment. In case of the third generation testing, we turn to continuous integrated assessment. So the focus of assessment switched from high-stake summative assessment more to low-stake diagnostic assessment. And finally, nowadays, we are in the time of the fourth generation testing, and we started to focus more on personalized feedback, tutoring, and of course, using AI in the field of educational assessment. So let's back to the first generation assessment. In this type, as I mentioned already, the first step in this developmental process was to prove that we can apply computer-based assessment next to paper-based assessment and face-to-face assessment. So it meant that conventional static tests were administered by computer with the advantage of automated scoring and feedback. Regarding this, first generation testing, I brought you the result of 2 studies. Both are focusing on the comparison of face-to-face and computer-based testing result and paper-based and computer-based test result. What have we learned in these studies? So the first study focused on first graders and second graders, and the second study focused on high graders, so fifth graders. The first study used exclusively figural items. The second study used numbers and letters too. Both tests measured inductive reasoning, but using different item formats. In the second study, it is an outline of the paper pencil format, and it is an outline of the computer-based format. In the computer-based format, students could see a progress bar, a clock, and the back and next button beyond those information which were available in a paper and pencil format for the student. Let's see the results. If you compare the reliabilities, we can see that in the first study, there were no differences in the reliability. In the second study, we could recognize some differences in case of the number series. But if we went more into the details, we figured out that it was because of the missing responses. But on a general level, there were no differences between the reliabilities in the first study and in the second study. And this was almost the case in our other studies administered for high graders. Let's compare the item difficulties. In the first study, which was administered for first graders and used exclusively figurative items, we could recognize some differences. And the amount of differences were also changing, as you can see on the figure. And these differences increased if the computerized version of the item contained many, many figures. So too many stimulus. If it contains many stimulus, then the difficulty level differences increased between the paper pencil and the computerized version. What happened in the second case, where we assessed fifth graders, so high graders, older students, almost all of the items behaved the same way. There were some differences noticeable in the field of number series and by open-ended question. And this is generally a conclusion of the other media comparison studies, that most of the differences were detectable by tests which were measuring math, students' math knowledge, and contained open-ended questions. Let's compare the test scores. In the second study, most of the students, 3/3 of the students achieved the same way. 4/3 of the students achieved the same way in both of the tests, but there were some students recognizable whose achievement was higher in the paper pencil or in the computerized version. Generally, in both of the studies, we could recognize that the paper pencil version proved to be easier for the students than the computerized version. This study, both of the studies happened almost 20 years ago. The situation is similar nowadays based on the Hungarian national data. Why? Because still our educational system uses mostly paper pencil tests at school level. And until our students face on a regular basis paper pencil tests, then they tended to achieve higher on paper pencil tests than computerized tests. One really interesting result, which we obtained almost 20 years ago, and this is still a valid result, the comparison of the missing responses. We can still today, we can see more missing responses in the field of paper pencil testing. Students willing to give an answer more in computerized version of the items than in the paper-based version. Let's go to our next study. The next study focuses on a comparison study between face-to-face and computer-based assessment. It's another issue. In face-to-face assessment, there is a test administrator who reads the instruction for the students, who gives the instruction of the students, who directly evaluate his or her answer and administer in a sheet of paper. In a computerized version, the computer gives all of the information to the students. The students had to give the answers on the computer by using a mouse or keyboard or touchscreen, and the computer evaluates students' responses. In this study, we have monitored third graders, and we have included several tests. In case of the speech sound discrimination test, we have used the same sample, the same students in both data collection. In the other areas, we have used different samples. Just a few examples from some of the tests: relational reasoning. In the face-to-face data collection, the instructor showed a sheet of paper to the students. The students could see this picture. The instructor read the instruction and ask the students to answer the item. The same task, the same item looked that way in a computerized version. So a trained voice read the instruction for the students, and students had to point on the bird which fulfilled the requirements. And afterwards, they had to click on the next button. So a short picture out of this assessment. This test contains 60 items. And this is another test, a speech sound discrimination test, where in a face-to-face version, the instructor read the instruction and pointed to the pictures, and in the computerized version,
this is a ship. This is a sheep. Now I will only say one of the two words. Click on the picture for the word I say. Ship.
So it meant that all of the students received exactly the same stimuli, the same voice, the same length for pointing on one or the other picture. And the instructor couldn't influence students' responses by different mimics or behavior that, no, it's not right, a picture, a point on the other one, because the computer behaved the same way with all of the students. So let's see the result. The result showed us that the reliability of the test increased in a computerized version. So the computer-based test proved to be more reliable than almost the same test, the same task in the face-to-face environment. If we compare students' achievement, we can see that again, that the students in the sample whose achievement didn't differed significantly in both of the media. However, there were students whose achievement was quite low in a computer-based version and quite high in the face-to-face version. Of course, we can raise the question, probably the reason could be that students couldn't handle the computer, or they had some difficulties with the computer. But then if we take a look on the inductive reasoning test, most of the students behaved the same way. So it meant that students didn't have any issues with the computer. These differences are coming just from the subjectivity of the instruction. So it means that even by lower graders, by first graders who are just starting school, it's more valid and more reliable if we apply computer-based assessment instead of face-to-face data collection. if we compare measurement invariants, we can see that beyond these two tests, inductive reasoning and the speech sound discrimination test, we have measured something differently in all of the other tests when we assessed it in a computerized environment or in a face-to-face environment. So on one hand, it means that it's even possible to assess students in a computerized version that way, assessing the same construct as we do in case of face-to-face assessment. On the other hand, if we must be aware of the fact that if we go to assess different construct in a computerized environment, it can easily happen that we assess something differently than we do it in a face-to-face environment, especially by young children. And I've raised already this question, what about using mouse and keyboard in first grade? What about introducing a computer-based assessment by lower graders? Of course, everyone could say, oh, come on, but all of the kids are using smartphones and using technology on a daily basis. Yes, but these technologies have touch screen. And I don't know how the situation looks like in Indonesia, but in Hungary, most of the schools have desktop computers at school level, and students had to fight with the mouse and the keyboard. And it's not for sure that they can use the mouse and the keyboard. So that's the reason why we launched a study, including almost 5,000 students, to take a look how quickly students can learn and how good are first graders in managing mouse and keyboard. So we assessed the mouse skills and keyboarding skills. We focused on those skills which are necessary for testing, so on clicking, navigating, and drag and drop. And in all the three cases, clicking pictures with different size and numbers. This is an example test.
The shepherds have brought the lambs home. Help the lamb's owner count how many lambs have entered the pen. Click on each and every lamb.
So as you can see, the students could listen to the instruction and they had to give the answers using the mouse. And they had to click on big elements.
Pop the balloons. Click on them.
In the third cases, they have to color.
Color the house. Color the roof red and the wall yellow. Click on the right colors and then on the parts of the house. If you make
Then in this case, we went in the direction of smaller elements, because if you could see, until now, students had to click on a few or more but big elements. And now we turn to smaller elements.
switch on the radio, click on the button on the radio.
And here they had to connect several small elements. And in this task, they had to drag several small elements. And of course, we have assessed their typing skill, keyboarding skills too. So let's turn to the results. As we can see on this item person map, the easiest was clicking on big elements. It was more harder if we asked students clicking on small elements. It was followed by typing, and the most difficult proved to be applying drag and drop with many, many small elements. So it meant for us, if we what does it mean for us, for the researcher? If we develop tests for kindergarten students or first graders, second graders, so low graders who just started the university and are not necessarily safe how to use mouse and keyboard, it's suggested to use big elements in the task, and if they have to click on small element, then they should click just one or two and not many. And it's suggested to avoid tasks where we ask students to drag and drop many small elements, because in these cases, students' keyboarding and mouse skills can strongly influence their achievement. And let's go further. What about using time limit for low graders? Time limit influence their achievement in a negative direction if we use more elements. So please avoid using time limit if you ask students to click on several elements. This is also the case by drag and drop. So time limit influence strongly their achievement, and even by typing if they have to type more characters. What about the learning effect? They learn really, really quickly. By all of the items which were measured the same operation for the second time, almost all of the items proved to be significantly easier for the students for the second time than it was for the first time. So it meant that we have even developed a training program for first graders and kindergarten students, and they can learn the most important skills in mouse usage and keyboarding students within 30 minutes within the confines of a small training program. And afterwards, they can absolutely use our tests, and the test results are not influenced by their keyboarding and mouse skills. So it means that computer-based assessment is applicable even by first graders and kindergarten students. What are the suggestions? Please don't use time limit. If the students had to click on big pictures, then you can avoid the influential factor of their mouse usage and keyboarding skills. If they have to click on 1-2 small elements, is still okay. Drag and drop with 1-2 big elements is also okay, and typing 1-2 characters are also okay. So we could conclude that technology-based assessment is applicable in educational context, even by first graders, by students who just starting school. Here are 2 publications which were written in this topic. And now let's go further with the second generation test. And before going further, I ask you whether you have any kind of question or...
Okay, Professor Gyöngyvér, we have one question. Okay, there is a question from Dayat. So the question is there any platform or application that we can use to assess or to evaluate writing text? I mean, the text or writing, something like that.
There are several platforms which is able to automate score written text, but most of these are focusing, or at this time in the 90s and until 2000, most of these platforms focus almost exclusively in English. That's the problem. Even nowadays, in the world of AI, we have such programs, but most of the programs are not for free. Even if you think on it, you can talk to your car, you can have some conversation with your computer, with using Siri if you have an Apple computer, or even now you can have a conversation with your Windows. So there are developments, and at this area, we don't use it on a daily basis, that we evaluate a whole essay in Hungarian, because the Hungarian language is a very, very complicated language. On the other hand, even in the system that we have developed, and I will talk about later on, the EDIA system is able to evaluate single sentences or words if you require to use it in the sentence, but it's not able to evaluate a whole essay. But of course, if we include AI in the field of assessment, then it's absolutely possible.
Okay. Okay, we still have two questions, I think. The second question is, it is possible to do assessment in attitude or affective and psychomotoric using the IT base?
Yes, and I won't answer this question now because I will have some slides regarding this issue.
Okay,
If we go to the third generation testing, to data mining, learning analytics, and behavioral tracking.
Okay, the last question for this session is that from the S2 Widodo. There is a report about the PISA, and the statement is PISA is still biased and unfair in terms of the technology mastery. It is a disadvantage for developing country. It is stated that it was a big problem by PISA committee. What do you think for that?
In the PISA assessment, there is a great emphasis to develop culture filters. They work a lot on it. So it looks like they develop a huge amount of items, and they administer these items in the different countries. And afterwards, they analyze the results and they select. So the selection process, which result is the PISA test, is a very, very long selection process. So they try to form so-called diff tests, so which is without differential item function. However, if we start to analyze, to run secondary analysis of PISA data, we can find diff tasks. So it's really a hard issue, and even in our researchers, as Soharto was also one of our PhD students in our doctoral school, and he knows that we regularly contact international data collections. And in these international data collections, we compare the even students' behavior, not just final scores, but how they behave during the testing, and how the construct is interpreted, for example, in Indonesian or in Hungarian context. And we must face the results several times, that even if we apply almost the same task, the same test, because you would say, okay, these are the same task, the difference is just in the language, but the students interpret the task differently. And if you have no measurement invariance, it means even you are using the same task, but you are measuring a different construct, because the students give a different interpretation, different meaning to the task, and it can cause differential item function. And this is also the case in the PISA, as it's really a large-scale international assessment. So unfortunately, you cannot really avoid this.
Okay. Okay, thank you, Jennifer. Maybe you can continue your presentation.
Okay. Now let's go further with the second generation tests. And In this field, yeah, we've mentioned PISA, TEAMS, and we can even talk about the other PIAC, about large-scale assessment. It gives all these were really a big booster in the field of educational testing and in the field of second-generation testing. This focus mainly on adaptive testing and on the replication of complex real-life situations. Now, what does it mean, adaptive testing? Adaptive testing is if the difficulty level of the test fits dynamically to the ability level of the students. You can realize this if the items came from an item bank. So imagine you have a student, and this is the student's real person parameter, which is indicated in the figure with the blue, but you don't know it, you want to know it. You administer the students a task with average, with mean difficulty, and the students solve this task properly. So the system administers a more harder task for the students. The students succeed on this task. So the next task will be more harder. And then it goes until the student fails on the task. And then he or she fails, then he or she receives an easier task. And through this procedure, you can recognize students' ability level with the help of about 1/3 of the amount of items as you would be able to do it with fixed items. So this is adaptive testing. Why is it important? And why is it even in the focus of nowadays in the field of assessment, in the field of learning as well? You will see it later on. What do I mean in this under this topic? Because age does not determine skills and abilities, and one size does not fit all. So we have learned it. These are also some of our results. If you take a look on students' development and on the differences between students studying in the same grade. So the x-axis represents the grade and y-axis represents the ability level of the students. The size of the cycle represents how many students are on the given grade, on the given ability level. In case of problem solving, you could recognize that the development is very slow, can be described with a logistic curve, and there are huge differences between students studying at the same grade. So it means that there are students, even non-graders, whose achievement is below an average third graders. But there are even third graders whose achievement are above an average ninth graders. But then you can say me, okay, this is problem solving. And problem solving is not really explicitly developed or trained, at least in the Hungarian educational system, which has a really, really strong disciplinary focus. What's the case in the field of math? Because our students had to learn math through the whole 12 years through compulsory schooling. Let's see. The results are similar. So there are huge differences between students, even in the field of mathematical knowledge, who are studying in the same grade. So there are students in first graders, second graders, whose achievement are above an average 8th graders. And also there are 8th graders whose achievement are below second graders or third graders. So what's the scientific result or the scientific background of this adaptive testing story? Because you have seen that there are big differences between the students. So it means that it's not really valid, it's not really motivated, and it's not really reliable to administer the same test to all of the students studying in the same grade, because as you can see, there are huge differences between the students studying in the same grade. So let's say this information table and imagine that we have just average ability level students in the sample. And in this case, average ability level means 0. And the item difficulty should be also 0. It means an average difficulty level. So the difference of these are 0. In this case, students had 50-50 percentage probability to be able to solve the task or the item right. And in this case, if you have a test containing 10 items, then per definition, we say that we can win the most information out of the test. This is the 100% information. But what happens if we keep the students, but we administer them a significantly harder test, which contains items with 2 logit difficulty level? Then the difference is 2 logit. The probability of the right answers is decreased significantly, almost just 10%. And in this case, you have 23 tasks in the test to be able to get the same information as you could have by administering proper task for the students, or you are working with a really big measurement error and the amount of the given information decreased from 100% to 45%. Or this is the situation the other direction too. If you have highly skilled students, you administer them the same test, but you have done it for average achievers. The difference is 3. And again, the strength of the given information decreased significantly. It's not even 20%. Or you must administer 53 items within the same test to be able to get the same amount of information as you could have if you fit the task, the items to the student's ability level. So that's the reason why adaptive testing is so important. However, these researchers around the millennium also pointed on the fact that if you use item level adaptivity, then you face the issue of item position, because the items behave differently in the different position. So the item difficulty depends on the fact where the item is at the beginning of the test, in the middle of the test, at the end of the test, which item is before the given item, and so on. So one of the answers in this topic was the cluster level adaptivity, multi-stage testing. What does it mean? We build small clusters out of the given amount of items, and we scale these clusters, and the students move between the clusters, and we apply cluster level adaptivity and not item level adaptivity. What happens if we do this? One of our former PhD students' research showed us that this blue line indicates the test information if we apply fixed format. So it means that all of the students had to solve the same test. And the x-axis shows the ability, the level of the ability level of the students. The y-axis shows the test information, the amount of test information. And what happened in case of the adaptive test, if you say in most of the cases, we could win almost 100 test information out of the assessment. But in all of the ability levels, we managed to gain significantly more information out of the students than when we used fixed tests in this study. If we compare the standard errors, we can even see then we are working with significantly higher standard errors by fixed tests, especially by lower achievers and higher achievers. So the main advantage of adaptive testing can be seen by lower achievers and high achievers. And all these results build the basis of smart education, which is nowadays really a very big issue in several educational systems. In this second generation testing story, the other issue is beyond adaptive testing, the replication of real life situation using second and third generation tests. What does it mean? Second generation tests include sounds and multimedia elements like this task. Yeah, this is a second generation test because it's impossible to administer a paper pencil format. If you administer test where the students can listen to the instruction, it can be also administered on paper pencil format. But this test is not, it cannot be, it cannot administered in a paper pencil format. And what about third generation test? Third generation test includes also interaction, where students had to interact with the task, and as a result of this interaction, the task changes by itself. Or another example. In this case, students can navigate within, like in a website. Of course, it's in a closed environment and not in a big World Wide Web. Okay, so now I turn to you. Do you have any type of questions regarding the second generation test?
I think no question yet in chat box. Maybe someone want to raise the hand. If you have a question, you can ask directly to Professor Gyöngyvér if you want. No one? Okay, I think not yet. You can continue, Professor.
Okay, and now let's go further. And we go in the direction to the issues which one of your questions referred on. Let's see the third generation testing and the main issues in this area: behavioral tracking and process data analysis. So it means going beyond the scores and even using more advantage of computer-based testing than automated scoring and so on. In this type of research, the focus is not just on the student's final score and assessing students' skills and knowledge, but monitoring even their behavior during testing and gaining more information out of the students based on their behavior during testing. So the first study, what I'm going to introduce you, compares face-to-face and computer-based trainings. These trainings are based mostly on computer-based assessment. This is the reason why I decided to choose this study. So the main question which was raised in this research: how to design games which are most beneficial for educational purposes, and do different game environments have different developmental effects? When this study was executed around 2010, no research was done in this area in the world beyond this. So it was the first research in the field of this topic. We have compared the effectiveness of a training program and inductive reasoning in 5 different scenarios. And within the training programs, we wanted to identify certain groups of children for which one of the environments was favorable. The main aim or the original idea from me was to track, on one hand, to track students' facial expression and to analyze their motivation, their reaction on the different tasks, and probably we can even scale afterwards the task not just based on their difficulty level, but even based on students' behavior on the given task. For example, if you administer a task which instruction contains soccer, then in most of the cases, boys favor those tasks more than girls and so on. So at that time, I had such ideas that probably even we can profile students not just based on their skill and knowledge level, but based on their behavior and attitudes. But then now I gave up because it turned to a really big issue, and then probably I come back to this idea a few years later when we have more AI in our systems. But at that time, it was really, really hard to execute. So how these 5 scenarios look like? We had a face-to-face environment. We had a face-to-face environment where students could work individually or in pairs. And we also had classroom-like experimental computer lab environment equipped with touchscreen monitors. In this scenario, students was allowed to discuss their ideas during the training, and the training was administered in a form of a mini game. The third scenario was also administered students the task in a computerized version, but we went to school and we didn't brought the students to the institute. We went to school and students had to use the school's ICT labs and the given infrastructure available at the school level. In this time, it was not permitted to talk to each other during the training session, and we also applied mini games by the training. In the fourth scenario, which was really similar to the third one, but we have embedded the training program in a Pac-Man-like frame game. And in the fifth scenarios, which was really similar to the fourth one, but we have extended the Pac-Man-like frame game with an avatar-based feedback. So it meant that we used 5 different scenarios. Here you can see the samples and the age and the gender distribution of the student. We also applied the pre-test and the post-test, which was a figurative inductive reasoning test. And so it differs significantly from the training items. This is an example from the Pac-Man-like environment. Here students had to go with the ghosts, and then they had to pick up fruits. And then if they managed to pick the fruits up, then they received the training task. This was a short video about our data collection. And parallel to this, we have also monitored students' facial expression, and we have used Ekman's theory about the 6 basic emotions. So it meant that we have analyzed students' marker points to know how they feel during the data collection, whether they are happy about the task, or do they feel frustrated, or do they feel anger or happiness, and so on. On the left side, you can see the original picture, and on the right side, the result of the evaluation. So it looked like this. So as you can see how the students work, and we put on these marker points on their face, and afterwards we have evaluated their emotion based on Ekman-6 emotions. So a big result of this study was, and it was very interesting, that at that time there were databases available which was developed based on Ekman-6 emotion on adults, but not on kids. And kids behave differently. And we had to face the issue that in many cases, when we saw anger, it was not anger, but concentration. So we looked back the videos, and we have seen that students are really strongly concentrating on the task to be able to solve the task properly, but the system analyzed as if they had anger. So it was really interesting. And another issue was that it was hard to identify students, because in some cases students came with glasses and next time without glasses. And then we had to identify that we are working with the same students. So there were really many challenges during this research. I really enjoyed it, and we have learned a lot. So, and at that time, it was absolutely state of the art, because there were also a few research in this area. And for realizing this, we have used just a web camera, no state of the art and top and extremely expensive technologies. So let's see the results. Basically, the research was on, so the basic of this research was training. So let's see how students behaved, whether they developed the same way in a face-to-face environment, like in a computerized environment, and how students' ability level changed as a result of this training. On the pretest, there were no significant differences between the groups, between the control groups' achievement, between the experimental groups' achievement, who received the training afterwards in a face-to-face environment, or an experimental group's achievement, who received the training afterwards in a computerized environment. Let's see the result on the post-test. In case of the control group, students even developed as a byproduct of school learning. It means that this period of time is a sensitive period for training inductive reasoning. So it's a very important result of this study. But if you take a look on the development of the experimental group in face-to-face environment, we could recognize an immense development. The Cohen D was more than 1. So it meant that students, on average level, students develop more than 1 standard deviation as a result of this training. It's a huge development. And now the question can be raised, how students developed in a computerized environment? And if I raise this question, and now I'm sad that we are an online environment, and I cannot say that please raise your hand who thinks that students develop more in a face-to-face environment or computer-based environment. In most of the cases, teachers think that students develop less in a face-to-face environment than in a computerized environment. And then I always ask why. Because in a face-to-face environment, there is an instructor, and an instructor can ask the students follow-up questions. So the instructor can personalize the training more to the need of the students than the computers can. Even in case of the computerized environment, students can ask for follow-up questions for help, but they could receive just 2 different questions and help within the gaming environment. But now let's see the result. the result showed us that the development of the students in a computer-based environment proved to be the same. So it means then we can even apply training programs in a computerized environment because they are also effective. If we take a look on the student development on students level, then we can and compare the different scenarios, we can say that the differences are almost the same. So it means that there were not big differences between the effect of the different scenarios, whether it was in a social environment or whether the training tasks were embedded in a frame game or they received an avatar-based feedback. So the added value of the training program was almost the same. And which is really sad news, which are really sad news, and it's also very important results and an indication on the Hungarian educational system. We went back to the same students in a year later, and we faced the issue that those students who were trained in this study, they get stopped and were waiting for the others. And the others continued, I mean, the control group continued that developmental process really slowly, as the normal development runs without explicit training. So it means that it's possible to train students' reasoning skills, especially inductive reasoning, really efficiently, even in a computerized environment. But if you train it, it's absolutely, but then you have to follow up this training if you want to keep the effect. Otherwise, they stop and they will wait for the others. Okay. And this is a short video about our other developments. We also went in this direction that this ghost should look like and should have such a facial expression like the students do during the training. So, and it's a short video about these developments. Okay, and then if you are more interested about these development trainings and the results, then these are to a publication which are going in this topic. And then still, if we remain by this search generation testing story, and the behavior tracking issue, going further, and I show you another study where we focused on process data analysis. But before starting this, I get back to you and I ask you whether you have questions regarding this analysis with emotion and so on, because one of your questions referred earlier on this issue, and probably the colleague has some follow-up question.
Okay, I think someone asked about the emotion, attitude, and psychomotoric question, if I remember correctly. Okay, Pak Ahmad Hibabullah. Okay, I think it's not responses. Okay, someone said thank you, but we have a question here. Miss Nahni Cahyani, do you want to raise your hand and ask directly, or I should read your question? Okay, probably I should read the question. Miss Nani, okay. The question is, can we integrate the computer-based assessment with the literature field in terms of, for example, contemporary novel, something like that one?
Yeah, if we are going in the direction of reading literacy, if your question refers on this, of course, I'm going to talk about this later on, that we also developed a huge assessment system which assesses mathematics, science, and reading, and within reading literacy, it's also possible. Or have you meant something else?
Yeah, I think that's related to something like doing a computer-based to literacy, or doing a literacy analysis to do contemporary novel, something like that. But we can wait your for explanation. Maybe you can continue the presentation.
Yeah. So you mean literacy? Yes, of course. I will talk about this later on regarding embedded assessment. And now go back to this third generation and behavior tracking issue. And in this study, we have used process data analysis. And we applied third generation tests. So it meant that students had to interact with the system. Students received fake stories. In this case, they had to feed a cat. They had to cat feed, meow, and catnip. These two cat feed had different effect on the cat's purring and activity, and they had to figure out how these two cat feed affects cats purring and activity. In the second part of the problem, they had to visualize the detected causal relations in a model presented under the interactive system. And afterwards, they received a given amount of purring and activity of the cat, and they had to feed the cat. They have to give proper amount of cat feeds to the cat to reach the given amount of purring and activity. So we have used this type of task in this study. And what we have learned, it was also very interesting, because if you focus just on the scoring and student scores, what we do on a regular basis at school level and daily basis, that students write a test, and then based on that test result, test scores, we say that you are a good problem solver, you are a medium problem solver, you are a bad problem solver. But if we analyze their behavior during testing, we have faced the issue that we cannot talk about medium problem solver. If you take a look at this figure, we were able to recognize 6 different profiles of students. Students who were non-performing explorers, students who were low-performing explorers, students who were low-performing or to intermediate performance on the easiest problems, but non-performance on the complex ones, students who were rapid learners. And by the way, if we focus on these students' average achievement, then we could say that these students are medium problem solver, because the average achievement is around 50%. However, if we go more in the detail, and if we start to analyze the process data, the behavioral data, then we could say that this is the group which has the highest potential in it, because these students were able to learn really rapidly during the test, and their achievement proved to be very low at the beginning of the test. Even they received very easy problems, and they finalized the test as an expert problem solver, even achieving very high on the most complex problems. So this is the most interesting group. And beyond this, we could recognize students whose achievement was very high and who performed very high on the easiest problem, but then underperformed on the complex ones. And of course, we have identified students with proficient exploration strategies. This was for 6th graders, how the situation looked like at university level. And this result even refers on the fact that if we are talking about developmental issues, then the development of skills and abilities is not just a quantitative something, but a qualitative too. So it means that we doesn't just change in the amount of how we acquire the given skill and ability, but even the quality of the structure of our ability is changing by time. If you take a look on these figures, you can see that we could recognize just 3 qualitative different class profiles and at university level and not 6 anymore. And again, we couldn't identify so-called intermediate strategy users, as we could do it just based on student scores. It's also another very interesting research results and just published last year when we monitored where students fail. What's the secret of those students who prove to be expert problem solvers or who are really successful problem solvers, and where students fail whose achievement proved to be very low. We focus on the transition of the students between the different phases of the problem-solving process. The first phase when they have to explore the system, the second phase when they have to visualize the detected relation, and the third phase when they have to move the system in moving. And we monitor the transitions between these phases. We could recognize 4 different transitioners: expert transitioners, advanced transitioners, beginner transitioners, and non-transitioners. And if you take a look at the figure, you can see that their behavior differed significantly. If we focus on the amount of the first transition, post transition, or the no transition fact. If we monitor the trends, and if I go back for a moment to this result, we could see that everything depends on the exploration. Those students succeed who spend enough time with the exploration and who recognize the right relations. And if students manage to do this, then afterwards they were able to apply, in several cases, this knowledge in the second transition. But we haven't found students, or just a few students in the sample, who were not able to explore the system properly, but were able to apply the information in the second phases. Because after the first transition, students received the right answer. I mean, the right connection between the input and output variables. But if the student was not able to gain this knowledge based on their own exploration, then they were also not able to apply it. So it means we have to support, we have to give enough possibilities for students to explore and to understand the problem environments, to gain the knowledge from this, from the problem environment. And if the students manage to get this, then they will be able to solve the problem later on with significantly higher probability. We have also compared the time spent different problem solvers in the different scenarios. And as you could see, non-transitioners applied almost the same amount of time. These are indicated with red. And advanced and expert transitioners recognize that the items is getting more and more complex, and they spend more and more time with exploration, problem exploration. And if we take a look at the interaction, the situation looks like the same. Those students who decided to have more interaction, to spend more time with the problem scenario, they managed to have also high scores at the very end. So time counts at this point, and it's not true that not necessarily true that those students whose achievement is high, they spend less time on the task, because it also strongly depends on the task what we administer for the students. If it needs interaction, if it needs really complex skills, then experts even spend more time with solving those problems. At least they spend more time with planning and exploration. So what's the conclusion? Scores does not necessarily cover final level of ability. We have to support students in problem space exploration. We have to give them time for visualizing their ideas about the problem structure, because it's also a very important part of the problem solving process. That we have to support the first transition, because the transition between problem exploration and problem representation proved to be really a key factor in the problem solving process. And this result wouldn't be possible without analyzing process data and without analyzing students' behavioral data and tracking. And these are some publications in this topic if you are interested. And now still by third generation testing, but referring on this path, how we moved from efficient testing to personalized learning. And in this path, we can face the changing role, the changing aim, the changing phase of assessment. And we came from Plessly testing machine now to the testing where we also monitor students' motion, emotions, facial expression, and even monitor their behavior tracking using real-life task. So this is on the test part. And what did we know in 2020 or a few years ago? We can develop complex real-world, authentic, high-quality tests, as you can see even in large-scale assessments. We have also learned in the last 20 years that the one-size-fits approach is not effective, as you could see regarding adaptive testing and regarding the big differences between students noticeable within the same grade. We have also learned that summative test results do not meet the individual needs of students, because in most of the cases, summative tests are fixed tests, administering the same task for all of the students. And in many cases, summative tests are high-stakes tests, and high-stakes tests influence students' future strongly than low-stakes tests. This issues was raised especially during COVID distance education, where several researchers raised the issue deleting all these high-stakes summative tests and going more in the direction of low-stakes formative and diagnostic testing, because we have to use assessment for supporting students' learning processes, and we have to rethink the sense of assessment. And in the next part of my presentation, I'm going in this direction, and I'm introducing you a diagnostic assessment system, which was developed in our institute, in our research group, and which is applied in Hungary. And this changes was already the main aim of assessment, and recognize the switch moving from summative testing, some high-stakes summative testing, to low-stake diagnostic assessment, to embedding assessment. So But first, going back to you, do you have any questions regarding analyzing process data or behavior data or any kind of issues in this field?
Okay, someone have a question related to previous presentation, but we have a question, one question in the chat box. Professor, maybe you can check it because it's quite long, but I will have to read it. So
Okay, the problem is that I cannot see the chat box. I can see just my slides.
Okay, thank you. I will have to read. So this is the research question from Head of Research Center for Education. So the first question is, what is the driver of technology-based assessment for the fourth generation? Is the first question. And the second question is, what is the role of educator, academia, and tech developer are in developing the digital assessment? And what necessary conditions are needed to ensure successful implementation of digital assessment, and how Hungary secure the data privacy of students?
Okay, so many of the issues we'll touch later on regarding the EDA system, so I won't talk now about those. And even research institutes plays a very important role in this regard. I will go back to this issue on my last slide. So it's a very, they
Okay.
play a very important role. So I will talk about this issue also. And the first question referred on the third generation task. Yes, because you know when computerized testing and technology-based testing, the main story started in 1990s. Around the millennium, large-scale assessment came, and they put a big impetus on all these developments, and we could recognize and really an exponential development in the field of computer-based assessment. New analyzing methods raised, for example, structure equation modeling, even Rush model was spreaded and even became regularly applied analysis methods. And parallel to this, computers and became available for almost all of the kids, for almost all of the schools. Internet became really high-speed internet. So if you think on the fact administering a task with multimedia elements in 1990, so it was impossible because the internet speed was so low. And even developing the item, it was really challenging. So we needed infrastructure, a lot of infrastructure development and methodological developments, that we reached that point that just student scores are not enough. And we can go further. We can use other advantage of computerized assessment than providing immediate feedback for the students, using the computers and using the features of prompt evaluation. And this resulted in this third generation researchers, which are mainly focusing on students' behavior. And slowly, it's not a question how students achieved an inductive reasoning task or problem-solving task or a mathematics task. The state-of-the-art publications are going about the issue how students behave during testing, because it's not really interesting anymore how they achieved on the task. Of course, it's important that you put it in the background as a control variable, but it's more interesting if you focus on their behavior tracking. And this is also the basis of smart education, because what's smart education about? Like, as you could see by the smartwatch, that you give students the task, the instruction, which are prepared for, where they have the enough background knowledge to learn that thing. And to be able to do this, you need we came back to the same topic. We need huge item banks. We need scaled item banks. We need to knowledge about students, knowledge and skill level, about their behavioral things. Because if you want to motivate students, you have to have the knowledge about what the given, how can you motivate the given students, and how students behaves during testing session. How much time do they spend with the task? Because all these gives information on their motivation. And if the students are motivated, then they are willing to learn and they are becoming better and better. But if they are not motivated, then somehow you have to reach that he or she becomes motivated. Because teaching unmotivated students, it's really a challenge, and it requires significantly more work than somehow reaching the fact that we have motivated kids, even in the field of assessment and training, who are interested in the training, who thinks on the training like, oh, it's a game, and they don't think about the learning, but they think, okay, I'm playing a game. And during this planning process, they are developing because they are well prepared trainings. So that's also the reason why the researchers started to focus really strongly on the analysis of process data, and let's see how students behave during testing session, and not just focusing on the right and wrong answers and on the final scores.
Okay, I think one question is not answered. How the Hungary secure the data privacy of the student?
Yeah, I will also go in this then later on.
Okay.
The system, okay? And now
Okay.
I go further.
Yeah.
Okay, thank you.
You can continue.
Okay, so, and let's go further with the diagnostic assessment, and what do we need to recognize such a diagnostic assessment, which can be applied in this form, in this embedded assessment, continuous assessment. So we need theory, of course, frameworks, like we need it by all kind of assessment. We need an assessment platform, and we need a huge amount of tasks, which are based on theory. And we don't just need the task, but we also need an item bank. So it means that we have to scale this task. We have to know the behavior of this task. So we need a scaled item bank. So let's start with theory. If you take a look, even the large-scale assessments have their theory behind their testing. So if you build diagnostic assessment system, you also need a theory. And when does diagnostic assessment system serve its function? If it's able to identify all important knowledge elements of what students already know, what they still need to learn. And if you take a look at the three main goals of schooling, which have remained clear from the very beginning of schooling and public education up to present days. So first, to cultivate students' minds, general cognitive abilities and thinking skills. Second, to develop usable, transferable, applicable, inside and outside of school context knowledge. Third, to transmit content knowledge accumulated and organized according to the values of the sciences. And they have to be present simultaneously in school education, and they have to reinforce each other. So this gives a three-dimensional model of knowledge, which was developed by Professor Csapó-Benő. And this model, this three-dimensional model, builds the basis of our assessment system. So the frameworks have been published in Hungarian and in English too. And afterwards, we have published the computerized versions of these frameworks too. But those books are available just in Hungarian. So this is our three-dimensional model. It means we are distinguishing the disciplinary knowledge, the application knowledge, and the reasoning type of knowledge. But at that time, it was a theory. It was about 2008. And at that time, it was a theory. no proof for it, whether it's true or not true. So these are the books. These are downloadable for free. So if you are interested, from the edia.hu website. And if you take a look on the reasoning dimension, it describes the interaction between students' cognitive development and learning, for example, mathematics or learning sciences or learning reading at school. The social cultural dimension, the literacy dimension, the application dimension describes the type of skills and contains the type of skills that make mathematics useful in areas other than the immediate school context. And finally, the disciplinary dimension describes the content knowledge described in the national core curricula. So this is the framework, this is the theory. And parallel to the theory, we started to develop, under my supervision, an assessment platform, the EDIA system. We also had some very important features that we fixed at the very end, which are those. This assessment platform should be learning-centered, should be an easy-to-use platform, but also including innovative possibilities. We have built an item builder model, which is able to administer and develop first, second, and third generation tasks. We are even able to administer both fixed and adaptive tests. We can use any device by the data collection, and we can use the system even by low-speed internet connection using extra proxy servers. We are able to give prompt and quick scoring after the testing session, and we also have a good feedback model with embedded visualization. So these are some examples from the test, some tasks, and even some pictures from our feedback model. And you ask regarding GDPR and students' identification. We do have in Hungary so-called students measurement code. This assessment code can be generated just by the schools, and it's like ID, but it's completely secret. So this identification code is connected to students code. Students code are available for everyone, but this assessment code not. So what do we do? We ask the schools generating students assessment code, and they have to upload the assessment code to our system. In this case, schools know which students is behind the given assessment code, but we have no idea. We don't know, and this is regulated in laws in Hungary. So it means that no one knows who is behind the assessment code beyond the school. So it means that if we use students' assessment code, we can assess them, we can give a feedback them completely anonymously, but the schools are able to give a meaning to these schools and to connect the results with the proper students. And the other way around, even if parents write us emails that please delete our students' results from your databases, we cannot do, because we cannot identify their kids because it's prohibited. So we don't know who are behind the codes. So this is a special developed assessment code in Hungary that we are using in our assessment. And the other thing, why is it really brilliant that we can even longitudinally follow students, because all of the students have just one single assessment code. This is like the ID code, that if the students receive this, that they will have the same assessment code through their whole life, from entering school until leaving compulsory schooling and having final school exams, Matura, for example. So it means that even we can run longitudinal studies, and even students can connect the same students' achievement year by year, and they can follow their development. So that's the answer for the earlier question: how can we manage students' identification, how it's secured from GDPR. And teachers receive not just students' achievement level, what you can see here in the table, but they also receive the reference point, the average achievement of the country, the average achievement of the region, the average achievement of the type of city or village, and so different reference points. Students receive the prompt feedback, as you could see with the piglet and the balloons on the left side. We decided to visualize their achievement too, because it's important for low graders. They cannot give a meaning for percentages, but they can count the amount of balloons, and as we can say, it's important for low graders, and they can count how many balloons they have received after the testing session. The maximum amount of balloons is 10. On the right side, you can see the web code, which describes, which is a type of visualization for the teachers. In this case, the red line shows the student's achievement, the green line shows the country level mean achievement, and the blue light line shows the classmates' achievement. So and the 4 axes shows the students' achievement in the 3 dimension and beyond. So in this case, we can say that we managed to find the students whose achievement is extraordinary in all of the 3 dimensions of learning, and he or she is not just at the top of the given class, but even his or her achievement is significantly higher than the country level achievement. Yes. This is another example for this cobweb. In this case, what the teachers can say based on the red lines, we have met a student whose achievement is quite high if we are talking about disciplinary knowledge, whose achievement is very high if we are talking about the application of knowledge, but whose achievement proved to be lower if we are talking about the reasoning dimension, about the thinking dimension. So it means if the teacher wants to develop the students further, then there is a great potential in this dimension of learning, in the reasoning dimension of learning, because he or she is really skilled in the disciplinary and application dimension. But if he or she will develop it immensely further, then their thinking skills must be developed. They also received text-based evaluation as feedback. Yeah, and this is the prompt feedback with Padlet. Let's see the task part. Our system, the EDR system, contains several thousand tasks based on the theory, and these tasks are already empirically scaled and labeled. It means we have about 25,000 tasks, which means about 100,000 items in the field of mathematics, reading, and science. These are some examples from our task. This is a task from the field of reasoning, the reasoning dimension and mathematics. It measures students' inductive reasoning in mathematics contents embedded in a famous Hungarian cartoons context. This is, again, also a task from the reasoning dimension. In this case, they have to drag the right solution This is a task from the application dimension. And as you can see, low graders can listen to the instruction. Low graders means 1 to 3rd graders. They can listen to the instruction. And through this decision, we managed to exclude the influential factor of students' reading skills in the field of mathematics and science, which proved to be very important, because if you measure science or mathematics, in many cases, reading skills plays a very important role in the achievement. But we could exclude this because students can listen to the instruction. And in this case, of course, it's all the same which pairs are put on the bed, because we accept all of the right solutions. Okay, yeah, this is again another task from the system. This is a disciplinary task. So you can see that they are colorful. Students can apply many different ways of answering, drag and drop down menu, clicking, coloring. So they really have many opportunities. This is also a task from the disciplinary dimension, which uses also buttons. On the right side, you can see the map of Hungary. The green dots shows the schools who are partner schools using the system, so almost all Hungary is covered. So we have many, we have more than 1,200 partner schools in Hungary who are using our system on a regular basis. What does it mean? The system opens 1st of September when school starts, and at that time schools can use our math skills, trainings and tests, and even a school readiness test. Then we launch our mathematics, science and reading assessments in late September, and for 2nd to 7th graders. But in this case, 2nd graders receive 1st graders task, 6th graders receive 5th graders task. And then we move further. In December, around Christmas, we close the system. We reopen it in January again, and schools can even use our mathematics, reading and science test. In spring, we have a reasoning skills assessment, so it means that schools can build a map, a profile of students in the field of how the students are skilled in the field of different reasoning skills, inductive reasoning, combinative reasoning, ICT literacy, and so on. And parallel to this, we reopen our big diagnostic assessment system again. And in a 3rd step, they can use our diagnostics test at school level. I've introduced you the theoretical model, which is behind the system, but it was a theoretical model for a really long time. And we decided to validate this model. And for this validation process, we have used a study. You can see the sample description on the slide. So it means that we have included more than 14,000 students in this study, 656 classes for 134 schools, and the proportion of boys and girls is about the same. These were all elementary students. Elementary means in Hungary from 1st grade to 8th grade students. If you take a look on our item person map, this is for mathematics and science, they look nice. So it means that the item banks are well structured and fit the knowledge level of the 1st to 6th graders in all of the 3 main domains of learning. We have also tested and validated the 3-dimensional model, and this is an example for the mathematics, but all of the numbers look similar in case of reading and science too. It means that the 3-dimensional model fits the data significantly better than the 1-dimensional model. And this result is also confirmed by the grade level analysis. So it means if you focus on just on the p-values, then in all of the grades, in case of mathematics, but as I mentioned already, the tables looks quite similar in case of reading and science too. We have proved that we can empirically distinguish this 3 dimension of learning: the disciplinary, the application, the reasoning dimension. It does, of course, not mean that they are independent, so they are correlated with each other, but we can distinguish this 3 dimension of learning. So it means that this model is already empirically validated model. And one step further, because one of the main aims of schooling, teaching students those type of knowledge which can be applied outside of school context too in everyday life. And if we monitor which is more important, then we have also proved the importance of reasoning skills, the reasoning dimension of knowingness to the disciplinary. If you take a look at this figure, you can even see that MG means the reasoning dimension. It plays a more important role in knowledge application after Y than the amount of the disciplinary knowledge. So it means that all these 3 dimensions are important, and it's not a good approach if we just focus on one of these dimensions, just focusing exclusively on the disciplinary knowledge or on the reasoning dimension. It has no meaning. We have to focus on all these dimensions in students' development and training. So we managed to prove, based on our results, what I've indicated you earlier, based on our smaller scale studies, that technology-based assessment is applicable in educational context and can be used really efficiently in developing students' knowledge and skills. And here are 2 publications which are going about the system and our task. And now I give the floor to you again before the last session.
Okay, Professor Gyöngyvér, there is one participant want to ask you directly. Nani, are you there? Yes, you can open your camera maybe and ask the question.
Oh, I'm so sorry because I actually just,
Okay.
sorry, am I audible? Am I audible?
Yes.
Hello,
Yes.
am I
Yes.
audible? Okay, thank you so much. Before I would like to say thank you, Prof, for your explanation. I think it's really mind-blowing for me because that's a very new things for me. And I think it's what to say. I follow all your explanation, and I think it's student engage more with technology through your explanation. I just try to like to conclude with my own thinking. Actually, I'm a literature student right now. I'm doing PhD in India, and then but I do love education because it is my concern, especially my basic knowledge is education, my bachelor and my MA. Actually, my question is, I'm interested in understanding how emotion can be analyzed in how to say, in computer-based assessment in contemporary novels, because as I learned here that the characters develop in terms of emotion and so on, and then this is how to see this projected in assessment, because so far in literary field, we usually do analyze through descriptive ways. So I just, from your explanation, it just gives me idea how to see the develop of emotion in terms of emotion, and then how to project that in assessment. I think that's all. Thank you for the time.
Yes, it's very important question, because in many cases, if we are facing assessments which are focusing on affective areas, for example, emotion, motivation, attitudes, in many cases, researchers apply questionnaires and they ask students how they are motivated, how do they feel themselves, whether they are satisfied, and so on. And students have to answer paper-based or computer-based version of the questionnaire. It's all the same. But most or all of our studies indicates that there are huge differences between questionnaire-based assessments and those assessments where we really look what the students do. Even if we're measuring collaborative problem solving, even if we are interested in their feelings, in their motivation, if they ask students how do they afraid of testing, or how do they motivated, or how do they think they are collaborative in problem solving environment, and we take a look on all the things in really achievement test, the results are in many cases not really converging. So it means that applying questionnaires, it's also an important part of educational assessment. But all the researchers must be aware of the fact that students' answers are influenced by many factors. What student thinks, okay, what the researcher or what the teacher expects from me, how to answer this question, or what could be the right answer. And that they don't really answer their feelings, their motivation, their collaborative level of problem solving, but they give an answer what they think they are expected to give, or this answer react on the students' meta knowledge about how they what kind of motivational level they have on about the feelings. So that's the reason why I'm even, and I force my PhD students to develop such tests and such test environments where we see students' behavior, where we are able to analyze their real behavior, as you could see by this facial expression analysis, that we monitor their marker points, and parallel in the same study we have also asked students about their feelings. And if we just analyze the questionnaires, then we could conclude that all the students enjoyed the training really much, and they were very happy during the whole training. They were very satisfied during the with the whole training. But if we take a look and if we go more into the details, then we can really see their behavior. And this is a big difference. And I think this is also a big challenge nowadays in the field of educational assessment, that we use those tracking technologies which are able to measure directly these affective fears. However, I know that most of the research in this field are questionnaire focused. So I know it's a challenge. It's still a challenge.
Okay,
Thank you so much.
Nani. Okay, thank you.
Thank you so much. Thank you for the enlightenment. Thank you so much, Prof.
Okay, the next question might be Dr. Helwiyah Makarim.
Okay,
You can
thank
ask.
you. Yes. How can a diagnostic assessment to help identify gaps in student in the learning process? Thank you.
Yes, my main dream is that the EDA system comes slowly to the point that we became adaptive, and it means that all the students receive tasks which are really motivating them, because there is a 50-50 percentage whether they manage to solve the problem or not. And we can use the system with quite low measurement error, and we can say the teachers what students know and where they need to learn, in which dimension of learning in the field of mathematics, reading, and sciences. At this moment, students receive the test and task without taking into account how they achieved earlier. So it can happen that even highly skilled students receive an easier test and the lower skilled students receive the higher test, because we are still in the scaling process. But if we manage to revise the system and to put it on an adaptive basis, that with a significantly higher probability, we will be able to say how students developed are in the field of mathematics, reading, and science. And you know, it's a very important information for the teachers, because normally the teacher can say just the students in the school, or some students in the school, and all the students in the given class. And they can give a score, and they can give a mark based on this environment to the students. But they have no idea about the issue, how developed our fifth graders are in the country, or how developed our third graders are in the country. And if they apply our system, that they also receive a feedback that your students in this level, and this level is up above or below the average country level achievement, or the average achievement of the students who are going to school in a village or in a big city, and so on. And it means that the teachers get information really on country level, how developed the students are in comparison to the average level developmental level. Of course, the perfect diagnostic feedback would be if we list also the different domains where the students need to be further developed. At this moment, we are able to provide this feedback on dimension level, but not on a lower level. Because even if we have 100,000 items, if you see the grades, if you see the topics in the field of mathematics, if you see the dimensions, and if you go lower, then you figure out, okay, you have 100,000 items, but it is not so many if you select it by that you have science, you have reading, you have mathematics, you have 3 dimensions, you are measured 6th grade, and you have many topics in the field of mathematics, reading, and science. And if you go back, then, okay, you have not so many tasks on everything. So it means that we need significantly more tasks to be able to be adaptive, even in a given small domains, and to give an absolutely proper diagnostic feedback to the students and to the teachers. So it's a very big challenge, but I strongly hope that sometimes we will be able to realize it.
Thank you.
Okay, thank you, Professor Gyöngyvér. Maybe we can continue for the next presentation.
Okay, so let's go further with the last generation, the 4th generation researchers, which are going in the direction of personalized feedback, tutoring, and which are more focusing on the learning processes. Because we switched the assessment from efficient testing to efficient learning. So we had the switch in the aim of assessment. So what do we know today? We have fine-grained process-oriented data about students' development. We have intelligent tutors, formative feedback possibilities. We have learning analytics, or the different options of learning and analytics. And there is a strong need for development of new learning theories. If you take a look on the many technology which are available, especially if you take a look on the AI, or if you take a look on the new generations, I mean the student generations, not the assessment generations. And somehow we also need the reconceptualization of research. We can conclude at this point that educational technology have brought about developments and challenges in theory, methods, and practice in the last 25 years. We have learned that technology-based assessment offers extraordinary opportunities in comparison to face-to-face assessment or computerized assessment. You could say we could apply multimedia elements, we could provide more valid, more reliable assessments. We can even monitor students' behavior, and we can do it on an objective way without excluding the intellectual subjectivity. We can produce more realistic, application-oriented, engaging, and authentic tasks. We can develop innovative items. We can realize more valid assessments, adaptive test algorithm, and provide instant, objective, and standardized feedback for the students. And this is where technology-based assessment and game-based learning are converging. It means that if you apply technology-based assessment, that nor the students nor the teachers should wait weeks or longer to receive feedback on the performance. And this is very important from learning purpose, because if you have to wait weeks or months for feedback, or then you lose your motivation, and even the results, the feedback loses their validity. Just think on video games, how they work. If you start playing a game at one level and it's too difficult or too easy for you, there you stop playing because it's not interesting. You continue playing the game if you receive tasks which are almost at your level. So 50-50% that you are able to solve this, or you fail on the test. So these type of tasks are challenging for us, are interesting and motivating. So imagine a game which administer you those tasks. But what happens if you solve 20 tasks and you have a prompt that, okay, come back in 3 months, I will let you know your results, whether you can go further and you can step to the next level or not. I'm pretty sure never ever will you game with this play again, because it's not motivating. If you receive a prompt feedback that, okay, you are nice, you can go further and you can continue on the next level, then it's interesting and you continue playing the game. So it's the case in the field of educational assessment and technology-based enhancement too. If we take a look on educational assessment technologies of the future, then what can we expect? Intelligent system incorporating sophisticated learner and teacher models. We can expect systems which are monitoring even the emotional, metacognitive, and cognitive states of the learners. They are at this moment more monitoring the cognitive state of the learner, but not really the emotional part, as we could recognize based on your questions too. This system should be able to interact with the test takers and with the learners, and they should also support collaborative and cooperative testing, because as we have learned in the 21st century, collaborative skills, cooperative skills became very important skills in the 21st century in comparison to the 20th century. They have to be able to apply adaptive models. It means that they must be able to administer students those tasks which fit to the students' ability level, cognitive states, emotional states, and motivational states. And also they have to provide sophisticated feedbacks for the students. But which is very important, and here I refer back to one of your questions, what's the role of research institutes and researchers in this field? And this is a very important issue, especially in the field of AI and in nowadays when we really have a huge amount of data. At this point, the responsibility of research institutes are very high because without them, if we have poor and misaligned assessment design, these will negatively affect students' learning. And we need quality data. And quality data can be gained just through tests which were developed by professionals, by research institutes. If we don't have quality data, then even our conclusions won't be valid. So the quality data are the only valid source for improvement and advancement in the field of educational system. And at this point, we have also danger with AI because many researchers, many institutes started to generate automatically items without professional controls, just using AI. And they want to generate item banks just using AI. At this moment, it's a good start. It's a good basis. But don't forget that we need still professional control beyond these developments. And, which is very, very important, do not forget different learning theories, because as I even see in many cases, some of the institutes and some of the researchers, some of the development started really strongly focus on the mathematical part of assessment, and somehow they even recognize from mathematical point of view smart education, but somehow they lose and they forget the knowledge what we learned from the different learning theories. What are these? The cognitive theory on multimedia learning, if you focus on the cognitive theory of multimedia learning, that is based on the idea that people have separate channels for processing verbal and visual information, and only a limited amount of processing can occur in each channel at any one time. So it means that we cannot put a lot of stimuli on in our learning test, because then students won't be able to learn in a very rigorous environment. Relevant motivational theories include interest theory, which holds that people try harder to learn when they are interested. So it means that they have to develop tests, we have to develop training programs where the tasks are really interesting for the students. The expectancy value theory, which holds that people try harder to learn when they value what they are learning. Or self-efficacy theory, which holds that people try harder to learn when they feel confident about their competence to learn the material. And self-determination theory, which holds that people try harder to learn in situations where they feel competent, autonomous, and related to others. So the challenges here identify evidence-based theory-grounded principles for how best to adapt the affordances of technology to help people learn, rather than, on one hand, expect people to adapt to every new learning technology that comes along. On the other hand, just focusing on learning from mathematical perspectives. And don't forget the main aim of schooling and the main aim of teaching. So the key takeaways are that technology-based assessment and computerized assessment is had a very, very long history, but from the millennium, we could face a very rapid development. And during this development, we switched the main focus of assessment from efficient testing to personalized learning, because now it's out of question whether we can realize efficient testing. We can develop a real-life test, we can develop very interesting tests containing multimedia elements, containing interactions. Now the main focus is how to support personalized learning by means of assessment. And from this point of view, we moved from the high-stake testing focus to a low-stake diagnostic testing focus, and from fixed testing to adaptive personalized testing. And finally, do not forget learning theories. Even in the time of AI, if you start to develop tests or tasks, or if you start to evaluate students' achievement just using AI. So the professional control beyond the results are still needed. Yes, so there are some pictures about our training programs and about our studies. Our kids are basically happy with the training programs that they took on these like games, and they don't really recognize that they learn through this process. And finally, I strongly hope that we can reach this point also in the field of education, and our computers will be able to personalize the learning task and our learning path for us. So, and thank you for your kind attention. I'm still waiting for your follow-up questions.
Thank you, Professor Gyöngyvér. Thank you for insightful and wonderful presentation. Maybe I will open the question and answer session just for 2 participants. If there is someone want to ask directly to Professor Gyöngyvér, please raise your hand. Okay. Nothing, I think. Okay, I think no question in the last
it
session.
was a very,
Okay.
very long session,
Okay.
so I can
Okay.
imagine how tired you can be.
Okay. Before I close this sharing session, someone, Jack Banderson have a question. So the question is how you think that your research is replicable to the other researchers?
Which study do you mean? Most of the studies are replicable. Of course, if you develop such a huge diagnostic assessment system as we have, then it's also replicable.
Okay. Yeah. I think that question is already answered. Okay, I think there is no question anymore because we just have 5 minutes left. So our Research Center for Education want to share the certificate of acknowledgement as a token for the appreciation. Okay, thank you for Professor Gyöngyvér as a keynote speaker in sharing session of technology-based assessment organized by Research Center for Education. Thank you for your participation. Thank you so much.
Thank you.
Okay.
Thank you.
Okay.
Thank you so much. Yeah.
Okay, thank
Thank
you.
you.
Yeah.
Hello,
Okay.
everyone.
Hi.
Okay, thank you. Maybe we because we already have the material and the component of the presentation, and Dr. Bu Tina, maybe you can give a last speech to close the session.
Right. Okay. Thank you very much, Gyöngyvér, for this is very comprehensive presentation about the digital assessment, the development of digital assessment. And I found that I think Indonesia is still in the generation 1. I think we have still many challenges to move to the second or the third and the fourth. So actually, this is very impressive, and I hope that through this discussion that we can get some ideas from your research. It's very intensive research, and then we also hope that we can have future collaboration with you actually with the University of Saget. So thank you very much again. Yeah, thank you for all. Yeah.
Okay.
I must also say a very big thank you for your active participation and questions. So these are very important. And of course, you have Soharto there. So we have really lively contact, and probably you can move quite quickly through this process, much quicker than we did, because we have the knowledge there, and you can of course use all this knowledge and possibilities.
Thank you very much. So we hope that we have later joint research on this issue. Yeah.
Yeah.
Okay, thank you. Okay, thank you, Bu Trina, Dr. Trina. Okay, I think we already grab all of the material from the Professor Gyöngyvér. And lastly, I want to close this sharing session. And then I want to say again, thank you for Dr. Tina as a head of research center for education. Thank you, Professor Gyöngyvér, for being a keynote speaker in our sharing session. Thank you so much.
Thank you.
Okay.
And have a nice day.
Have a nice day. The participant may leave if you want. Thank you.